will start with some questions possibly, but as earlier, please ask us. The idea is to engage in a dialogue. What I would like to ask everybody is, what is the future of multimodal AI? What do you see in the next 5 years? It's hard to predict the future, but this has not prevented us from doing it before. So I'm curious.
You want to start?
Maybe we go from Dylan.
Yeah, so I think systems sort of being natively multimodal is probably a bit of where we're headed. There's just so much benefit from being able to connect different kinds of ideas, right? Like I've been very excited about those results with kind of vision language models in terms of communicating goals and being able to, and the main reason that's valuable is because we can take language descriptions and project them into this other space. And now that gives us kind of another handle on controlling AI systems and moving them through. And so I think there's a lot of sort of overall momentum and kind of direction within that. I'm also pretty excited about the results on kind of developing redundant predictions based on different modalities and using that in order to increase overall reliability. I think this is like related to other kinds of things where you're integrating sort of like system 1, system 2 kinds of approaches within AI systems where you're maybe planning based on predictions from a language model and then checking that with sort of chain of thought or other kinds of techniques. And so having like multiple different prediction pathways that all get combined and integrated seems sort of like the future. So that's maybe a different kind of multimodality in a way of sort of bringing in different reasoning processes as well in the long run.
Okay.
I think in health, which is inherently multimodal, right? Like you go to the doctor, they take tabular data, images, they write notes about you. The interesting thing is combining each of those in a relevant way for ultimate risk prediction. So for example, we have a project that we're doing on predicting diabetic risk, whether you're going to become a type 2 diabetic up to 2 years early, right, before the diagnosis would have happened. And what we found is that the models that we're using that are using all of this clinical information, they work really well on everybody except for young people. And then when we added in the genomic data, so we asked for these genomic markers from the All of Us data set, which is this NIH initiative to have a broad amount of data across the United States. When you add in the genomic markers, it does really well in young people too. And that's because if you develop diabetes as a young person, it's probably not because of lifestyles, right? It's not because eventually you were not exercising, you were having too much sugar. It's because there's a genetic risk, right, that is extremely strong and almost independent of lifestyle factors. And so I think we need all of those modalities in order to understand relevant risks and do early prediction in a healthcare setting. And that's really exciting. There's a lot of really cool new work in trying to not just use these modalities we've had around for a while and haven't really combined in the right way, but actually make new modalities, right, with a bunch of wearable sensing and try to integrate that with the more traditional health data that exists within electronic healthcare records.
Antonio?
So I think that, of course, there is going to be an explosion of applications and not just robotics and healthcare, but it will create a lot of excitement. It's creating a lot of excitement and empowering a lot of applications that we're maybe not even thinking about. I think that there will be a lot of that. But on the technical side, I think that one thing that is still missing is multimodal AI is not really multimodal. It's still mostly language models that are plugged with other sensors. But they are not genuinely multimodal, and I think that there are now efforts to make them really multimodal, natively multimodal, and I think that will be an exciting technological advancements. But I think that another thing that also relates to the technical side is the sensor side. Like the way that you generate this multimodal data, right now all the sensors have been developed so that they interact with humans or they interact with simple machinery and simple circuits in order to do something. Now, if you know that this thing will be the input to an AI system that can kind of take, complicated data and be able to do something sophisticated with it, it will change the way that we develop sensors. It will allow us to have sensors that are wilder and more broad in what they can measure outputting something that is super high dimensional and structured and still be able to learn something with it. So I think in the technical side is going to change how we develop sensors.
I think actually just to add on top of that, there's a lot of really interesting work going on right now on training what people are calling like foundation models for robotic contexts, where you're having a single kind of model that's outputting plans and actions, and then being able to apply that across a whole bunch of different robot bodies and things like that. And so being able to adapt the same kind of core technology to across sensors and in different sort of embodiments is like another piece of this that's pretty exciting.
Following up, I'm actually curious on your views on how these developments that are emerging in multimodal AI will affect education. In other words, I'm curious. I made some prediction myself, but I'm curious on your views about, MIT does not have, I don't believe, last I checked anyway, although this is changing by the second, classes. My students take computer vision models, classes, language classes, regular machine learning classes. What do you expect the future will be? Let's go the other way now.
So I think that's going to be quite exciting, and there are a number of efforts at different institutions, and also at MIT, about studying the power of generative AI for education. And so there are, for instance, a researcher at ECS, Dirk Englund. He has developed a tutor that is capable of answering questions about quantum physics and being able to guide the students through exercises. So it's just a complement to teaching that allows for the student to interact with the system and be able to ask questions and check whether the reasoning is correct or not. It's still very preliminary, but they've been using it in class, and it's an interesting exercise. And there is another project that is led by Cynthia Brasil on trying to create a more structured AI tutor that uses also best practices in pedagogical research in order to understand what is the kind of interaction you should have with a tutor so that it maximizes your learning. And it's not a replacement for teaching, but it's like an interesting complement where having an AI system that helps you to learn has a number of interesting advantages. Like sometimes you don't know something and you're in class, you don't dare to ask a question because you feel like they're going to evaluate you and realize that you don't know that material. With an AI system, you can just ask, and it's not going to judge you if you don't know how to do something very simple operation, and it will help you to learn some of those very basic things that sometimes are just hard to learn because sometimes we don't dare to ask those questions. So I think there is a lot of potential. There is also the danger that suddenly becomes a replacement for normal teaching, and then you have like a lower quality teaching that is just very broadly available, but it's lower quality. So it's going to be an interesting space where we'll have to be very careful with a lot of different things.
I think first, are you sure the AI isn't judging you? I mean, I feel judged sometimes. I ask a question, it's like, oh, you don't know that? So I think in general for education is one of the most obvious settings where we need to both invest more in understanding multimodal AI and generative AI, but also in using multimodal and generative AI. In other cases, there's always questions about exactly how much, and do we care about whether a model stays exactly within its support set. With medical education, actually, there's been some really interesting proposals where a lot of the benefit when we deploy tools for clinical decision support, you don't get it in, radiologists who have been practicing for 30 years. They've seen everything at this point, and they do not need an AI to provide a helpful hint. But we do see that it improves outcomes in almost every paper. This is not just work I've done. It's work that I think a huge community of AI and health people have done. The improvements are for people who are in training. So medical residents or fellows tend to get huge benefit from having these sort of reminders or alerts about, did you check something, or have you considered this outcome? And so I think, the advantage also with generative AI is some of what happens with medical training now is this think aloud, what will happen? What are all the possibilities? Does this look like a tumor? What would happen in 5 years, right? What would happen if this person had an unhealthy diet, or if they had this specific medication, right? Which is, I think, it does not have to be a completely counterfactual, causally valid projection in order to be a useful learning tool for a clinician to use to think through outcomes, both themselves as a provider, but also with a patient and potentially their families.
I think I'm pretty excited, sort of, I guess, specifically for generative AI systems, being able to use them for rubber duck debugging for students. I think, having the duck sort of talk back to you and generate ideas, like my program's stuck, what do? I spent a lot of time teaching sort of intro CS courses, not this past fall, but the previous two. And one of the biggest things you'd see is students who just get stuck. They're there, the program doesn't work, and they just don't know where to start. And that was like one of the most common questions that we would get during office hours or lab hours, was just people who are there, like, my code doesn't work, this happens, and I don't know where to get started. And I think that, like, these types of systems as a way to go through and say, hey, here's what I'm seeing, what are some things I can try, and like helping people sort of learn that sort of interactive process of debugging and sort of finding a hypothesis and then actually going through and checking it can really kind of help get people unstuck. And I think this was something that people used to be, is both one of the hardest things to learn and also is something that, like, the sort of auto grader, sort of, here's a program, type in your thing online, you see immediate feedback, it works or it doesn't work. I think it makes that much harder to teach this skill. And so I'm hopeful that this as a technique will help, not for sort of telling people the answer to things, but just giving them, you're stuck, here's a thing to try, here's how to get yourself unstuck. Another sort of direction, and this is actually inspired by a student from my class this past fall, where I taught a seminar course, and we had a student in the class whose research is on AI tutoring. And what she studies a lot is kind of aha moments in the context of sort of learning. So an aha moment is like the moment when something clicks. And this is actually something that's pretty well studied and something you can see a good amount of. That, like, if you're a really good teacher, actually what you're doing in one of those close interactions is you're working with a student, trying to get them to one of those moments. And when you see that happening, that's not something based only on the text of what you see saying or on them just sort of answering a test and their test score going up, but there's a real sort of multimodal aspect to that. Right, you're interacting with them in the moment, you're sort of seeing them, and then you sort of know that look on someone's face when their eyes sort of light up and it clicks. And like that's the moment when you know you're sort of ready to move on to the next thing. And so I think these types of kind of techniques, if you're thinking about automated tutoring, this is where like multimodal interaction might be really, really helpful in being able to connect some of this, like what's going on under the hood on the part of the students that you're interacting with in tutoring, and sort of helping structure and pace out lessons as a result.
I have one final question, and then perhaps we open it for the audience. This is the more risky question. In the beginning, at around 9:30, we had some of the leadership of ECS in the audience. Would you consider proposing, given all these developments, the field is definitely increasing, that we might want to start educating people who become lawyers or doctors, people that we don't educate today. In other words, our students, we have 26 departments in 5.5 schools with Schwarzman. So would you consider enlarging our offerings to educating people that we don't currently educate, by and large? It's a risky question, but I'm curious on your views. All of us are in the Institute for some time.
No, I think it's a pretty critical aspect. The world is sort of changing fast enough, and if these technologies are going to have the impact that we think they might, actually kind of making sure that the professional class that's already gone through a fair amount of education is up to date really is kind of more and more important as that pace of change picks up. So actually, tomorrow I'll be involved in one of those where we do a little bit of this more sort of set up with individual companies, but we have Accenture kind of coming in, and we're talking with them about generative AI and laying out a bunch of these things. And I think the question we have to be thinking about is what's the real value add that we're providing in terms of helping people think through what to use. And so, for my goal, it's, I have a little bit, I like to talk about alignment and all of that kind of stuff. But I think it's really important to talk to them about, like, what are the basic skill sets for evaluating these systems? What can you trust? What can you not trust? Where should you be really careful? And where can you really effectively get use from this? And I think that type of practical instruction is really helpful. And, there was that sort of famous example, I think it was last spring, where there was a lawyer that got in trouble for using ChatGPT to draft kind of a brief within court, and they submitted something with sort of made-up cases in it. It actually just happened again a couple weeks ago in Canada, so clearly the message is kind of not getting all the way out if people are kind of making these really basic errors in the way that they're interacting with these systems. And so this kind of professional education, I would say, for lawyers and doctors certainly, and also policymakers to some extent, helping people kind of raise their basic level of understanding of where can I trust these systems, where can I not trust these systems, seems pretty crucial. So I don't know, maybe I just signed myself up for extra work, but.
I think we definitely want to be part of broader outreach with education. I do think, as fantastic as multimodal AI is, and as I think as amazing and a technical accomplishment foundation models generally, and the GPT models are specifically, I think that the problem is you've now moved technology that used to have some barrier of entry. You had to have some sort of background enough so that you could download a model and maybe get it running. And, there was some amount of debugging required. Now everybody can use it, right? Which is a wonderful thing, truly fantastic, until doctors. So, OpenAI can see the IP addresses, right, of people who are using ChatGPT. And they were telling me, do you know how many IP addresses from inside hospitals are just pasting data that looks like it's protected health information? And so they had to put this alert on the ChatGPT site saying, like, do not paste medical records or, legal documents. Don't paste anything in here. This is not intended for that use. But again, it's because it's something that is broadly available, and it's in a medium we're all used to using. It's natural language. It's just typing. You don't have to edit the code. You don't have to compile anything. You don't have to get it running. It's just there. Just use it. And so I think now that we've moved from having some sort of barrier to entry into, these very natural interactive environments, it's extremely important that we have general education, not even about when to trust the models, but just like when to use them and when to not use them. And the fact that they're going to incorporate data, and that might be a violation of some kind, right? That hallucination is not this, evil adversarial thing. It's generalization in a direction you didn't like, right? When it generalizes in a direction you like, you're like, oh, it's brilliant. And then when it doesn't, it's hallucinating. So I think having that sort of less anthropomorphic, slightly more centered discussion about technology is important. And aviation, one of the reasons we picked it for the examples I went through is they went through this. They went through all of these analyses. They did large-scale human-computer interaction studies in the 60s and 70s and the 80s, both in aviation and also for NASA with spacecraft, about when you give people information, how should you give it to them? How directive should it be? How much information can they process without losing out to automation bias and not doing intelligent decision-making? We haven't done any of those studies, right, in any of the fields I'm talking about, right? We haven't looked in medicine at how you give people information in such a way that it's useful without short-circuiting their critical decision-making skills because you've overloaded them with, oh, it's so fancy, I must listen to it. And so I think that that's something we should invest in.
Yeah, so I think that there is an agreement that that's important. I think that, for instance, part of the mission of the College of Computing has been in creating these common ground courses where they try to reach out to across MIT in order to teach, to introduce classes that introduce computational thinking connected with other disciplines. So to make it like really broadly available, having education that is broadly available across multiple disciplines within the institute. I think that, for instance, when I was a kid, I remember that everybody was saying that having some programming skills and knowing how computers works was going to be very important. And people have been saying that for a long time. And now it's just obvious that it's very important. Like now there is no way around that. And still, not everybody is educated in order to understand how computers work, or having just some very simple programming skills. And now we know it's just essential. It's not important anymore. Now it's just essential. And so I think that is just very important.
I would like to, given that Dan is in the audience, I will tell you one comment that I have. I think MIT is moving in the right direction. The Schwarzman College has been, in my opinion, this is not an empty compliment. I believe it's in the right direction. I believe there is more things to do. In my view, the way we educate is by and large not that different since the period I was a student. For example, we take electromagnetics the classical way with homeworks and so forth. We have improved the computation now, as Antonio says, very important. But my thinking is that for many fields, I believe AI can change them and therefore be part of the early undergraduate curriculum. For example, I'm not an expert on this, but I've seen some of my friends giving lectures on design of materials in material science using AI. I've seen design of molecules that have therapeutic properties. Very good work is happening here, and it's endless. So it is still in the research mode. It's still still on the promissory in many ways. It's not yet a fully proven technology, but I would not be shocked if in the next 5 years we have even some of the early classes, undergraduate classes in your favorite X being AI NX. So I think it's one of the most exciting, I've been at MIT roughly 40 years, it's one of the most exciting periods, at least in my lifespan, to see the promise of this and also learning about things that I need not know about with the use of AI. Earlier in the morning I told you a bit about methodology, which I don't next to nothing about. I know Epsilon now, but I think it's a fantastic opportunity, especially you have a lot of young people in the audience, admittedly positively inclined for this field, given that you are here. But I feel like an evangelist. But I'm very excited about the future, and also the future of an environment like ours, where I think the Schwarzman College can play a role in not only, but also on the vertical side. But I would like to open it for questions, disagreements, comments, whatever you like. Yes, sir.
Okay, first, thank you all for the inspiring talk today. So my question is more about related to the first question you have. So it's about the future of this kind of multimodal AI. So I'm wondering, in terms more specific, in terms of the research that here, going on across the universities, what's your opinion, towards any kind of shift or changes of the way that research is conducted in the institution, by from the influence or any impact from this kind of development of AI in the next few years? What will you imagine any kind of...
I can tell you my personal experience, not the theory, and then perhaps my colleagues can also. So my personal...
Let's repeat the question.
Yeah, what I understood the question to be is, you are a student here, I take it? So he's looking how these new developments will affect the future of research in at our environment, I would imagine. Approximation reasonable? I can tell you how it affected me and my group. So at some point, early in the morning, I told you I was a bit skeptical about the lack of interpretability of this area in very critical decisions, life and death decisions. But at some point, I said, come on, really, there's a huge progress going. So I became all in despite my hesitation. So how this affected? So I have now groups of, in my group, I've been 40 years, it was more mathematical research, models and so forth. Nowadays, I work very much, particularly in healthcare. This is where I have put a lot of effort. So my students utilize multimodal AI in hospitals. We work with doctors. So a project is not like, I sit in my office and think. Rather, I talk with physicians who have real issues, and they pose questions to me that I have never asked before. And I believe that the collection of tools this multimodal AI has is capable of at least advancing. So the nature of my own work became more empirical with physicians and students. People have close relations and so forth. That has been a change. Antonio?
I think it's impacting a lot of areas. There are a lot of areas of science where they interact with very complex sensors, complex data, trying to model complex systems. And all of these areas have seen a lot of benefits from using AI tools. And they are seeing a lot of changes in how research is being performed, from chemistry to material science, biology. All of these areas is now like quite common to have a lot of researchers using these tools. Not just now, actually. They have already like a long history of using these tools, but now they are kind of starting to have really exciting results out there.
I think the biggest thing that I've seen shift is impact. So when I did my undergraduate, there was a computer science department and there was an electrical engineering department, and they were in separate schools. One was in the School of Engineering and one was in the School of Science, right? Not like here. And anybody who went through the College of Engineering had to take the engineering ethics class, which is part of being ABET accredited. Like, you can't be an accredited electrical engineering program that spits out, people without having this ethics class. The computer science department had no such class. And generally, this is, there's no, we actually have a lot of efforts around this at MIT, and I think other departments are also doing the same thing. There's no similar akin to engineering ethics class that's sort of centrally dogmatic in the training of computer science undergraduates, where they show you the bridges falling down because an engineer stamped something they should not have, or an electrician verified a plan that overloaded and a building burnt down. Right? Where they really instill in you that you as an engineer, you have a responsibility. Your research, your technology, your innovation, people are going to use that. It's going to impact people's lives. And I think for a long time, computer scientists were sort of exempt from this, right? Like, we don't impact people's lives, right? We sit in the cloud or on the computer, and that's all fine. And that's not true anymore. And so I think actually this is an example where the innovation and the deployment of things from our field have outpaced the way that we think about our role in society. And I think we're seeing that change a little bit, where there's a realization that we actually affect everybody's lives now in a really core way. And so we need to bring that consideration back into all the things we do, into the research, into the deployments, into the innovations.
So I think one of the big differences that I see is just related to the scope and size of the models that people are using, and the way that changes some of the day-to-day aspects of research. I think, I had a project that I was excited about working on with a master's student last year. It was building on some prior work we'd done in multi-agent RL. Multi-agent RL is very cool, also a real pain in the rear to actually get working. And one of the main reasons for that is that the tooling, it both requires a lot of compute to run it yourself, and the tooling for it is just nowhere near as good as kind of the tooling that exists for interacting with language models and running training on that. And so there really is a sense in which access to pre-trained models and access to sort of open source coding, sort of software development kits that are being iterated on and updated on by large groups kind of collaborating on this shared interface really sort of makes it a lot easier to do certain types of this work. Like, there are certain questions that are just massively easier to do because either you have access to a model that's pre-trained for it, or you have access to sort of pre-existing sort of code books that you can run things and sort of evaluate really quickly and sort of look at metrics. And so one of the real questions that I sort of have going forward is how we're going to maintain kind of work on these sort of other areas that don't already have that kind of large global investment in developing the infrastructure and tools for them. So maybe that's, we've been really positive today in this conversation. So maybe I'll throw in a little bit of negativity. Well, actually, no, I guess you've had some.
Really negative.
One in the back.
If you can go near a microphone so that...
Sorry.
And maybe one or two of us answer the question so that otherwise we will exhaust.
Thank you all again for all of this. With all the excitement in the general public around AI and ChatGPT, but also knowing that you as experts really understand the warnings people should be aware of, if you were to do like a 2-minute news story with CBS News or a major news organization where you had 2.5 million people all in one setting, what would be the headline of the story and what would be the major warnings that you would want the general public to know?
That's an easy question, maybe.
Why are we pointing at me?
No, I'm not pointing at you. I'm asking collectively.
Judy is pointing at me. For health specifically, or do you mean for generative AI? I'll answer.
Anything I take.
Okay, I only have 2 minutes. It would be number one, right? We need better regulation of technology in spaces that impact humans. And we need to think about computer science the way we've been thinking about engineering, where we have, stamps of approval, we have audit systems, we have evaluations, we have accreditation, right? Like some of those things don't transfer. And some of them could, right? And so we need to shift some of that mindset. That's a general thing, right? And the second thing I would say is the reason that AI is, potentially killing you right now is because it's learning from historical data and healthcare system that doctors kill people. It's not doing it for fun, right? It's looking at historical data and it's mimicking it. The errors in there, all of the malpractice, all of the things that is not by federal law required to be retrospectively labeled and is not done on a volunteer basis by hospitals because it's a liability risk. And so if we're concerned about AI doing something unjust or harmful to humans, then we should add rules that regulate those human systems now so that it's not in the data that is used to train those models.
Maybe I can add something else, is that I completely agree, regulation is needed. But I would like to give the example of nuclear energy. Nuclear energy in the 40s, the first application of it was catastrophic for humanity. But over the years, it became, France is at least 60% electricity, nuclear energy to power it, and many other. There are trajectories that are on the positive side, and there are trajectories on the negative side. Some of them catastrophically. There are naysayers that people say that AI might have and is an existential threat to society. I have one of my doctoral students, comes to me every time we meet, reminds me of this. So my belief is regulation is an important aspect to raise also the social consciousness, because people hear about it and so forth. But it's not all negative, in other words. I'm excited about its future, but it's not a future without challenges. And I would like to, nuclear energy is an example of the various trajectories we have developed. And hopefully we are going more on the positive than on the negative. Another question, maybe somebody would go to the microphone. And then maybe Dylan and Antonio will answer the next.
Thank you very much for a very insightful talk. I will just refer to the example what you gave regarding, the airlines and the female patients and the male doctor. Building on that context, now we have data fusion from multimodal areas, multimodal data coming in, and we are trying to generate a solution out of it in the AI. How do we brace against correlation rather than causal relationship between data? And how it is going to impact us subsequently. And second point was regarding Antonio's point regarding, we said that we've almost run out of data and we're trying to simulate and generate more data based on the previous data. And how do we prevent that data getting corrupted again because of these correlation data?
We'll let Antonio and Marseille answer this question.
I start with the last one.
Last one. Let's answer the last one first.
Yeah. So that's a very important point. And so, on one hand, it's very important that you know which data is synthetic and which one is real. I think that that's already a problem in some settings because synthetic data gets generated, that gets posted out, and then the systems get trained also with that, and you actually don't know which one was synthetically generated, what was real. So that's going to be a mess in that regard. So I think that properly labeling the data is really important in order to train these systems. But there are also interesting ways in which you can create synthetic data. You can create synthetic data because you have good models of the physical world that you know that they work relatively well, like in meteorology, for instance, and you can use those to supervise some of the data that is being that is part of your training set in order to produce new data that follows the rules of your model. Now, when you train the system, at least it starts by having this really good physical model that you know works to some degree, and then it uses the rest of the real data in order to learn further. There are a number of challenges, and I'm sure that Marcia will happily talk about all of those, because as soon as you start creating synthetic data, there are going to be a lot of blind spots that your model will start generating things that you are actually not aware of, and it gets reinforced into the training. So there are a number of issues that come with that. But once you run out of data, you have to start developing the techniques to generate synthetic data that is useful.
Marcia?
So, not to be reviewer two in this crowd of very positive people, but there was a really fun example where there was a public evaluation done of several large vision language models. So this would be, diffusion models like Midjourney or DALL-E, or like many models where you can ask in text, make me this picture, and then it'll give you the picture back, right? And they were asking for pictures of doctors treating, pediatrics. So give me a pediatrician. And they tried varying the demographics. The model won't generate black doctors treating white children. It won't generate it. You can say it again and again. No, I want a black doctor. Like, it will not generate this data. That's one very vanilla example, right? There's a very popular vision language data set that's been used by many, many people. This is the Leon data set that's been used in many embedding models and in many in production models. It has images of child abuse in it. Nobody found that, right? There's lots of synthetic data that's been generated from that. We're not checking every data that is generated from these models, right? And so there's both issues with, as you're suggesting, correlation. There's no causal reason that there's no black doctors, treating children in this training data, right? This is a correlate. It's like, who takes pictures, right? What images can you find online, right? What associations has this model learned as a result of the sampling bias that exists, and then just the plain societal bias that we have, right? There have been some really good, so I am very negative. Antonio knows this, which is why he said this. I'm very negative about synthetic data, about generating data for models generally because of these problems that we've seen currently. But I will say there has been a lot of effort recently in some papers I reviewed in some of the large machine learning conferences to specifically try to generate data to augment for known gaps in vision data sets, right? And I think that's a fantastic effort. I think that the efforts need to improve, right? And there's a lot of work to go. But I think that that's a really succinct example of where we know humans, the most popular example of this is it's an old example. It's from, I think at this point 6 years ago, there was a challenge at the big machine learning conference where they said, classify these images of weddings. Only North American weddings are weddings. Because if you're an Indian bride, you're not wearing a white dress. If you're two men, there's no white dress. Like, none of these weddings of anything except for a very stereotypical, light-skinned woman wearing a very nice long white dress were classified as weddings. Everything else was performance art. And so these things don't matter. It's like the race classification from a medical image. Does it matter that this one model's biased? No. Does it matter that these models can and will and are currently being used by people who have no awareness of these biases to make decisions about who gets offers for things or discounts or jobs or whatever it is, right? Healthcare benefits. It does matter. And so I think the problem is we know the correlations that we have right now in multimodal data are bad, and perhaps generative data can address that.
Last word, Dylan.
So I think maybe I very much agree with what Marzia said, and I think especially when you get into synthetic data, one of the real shifts that might help us sort of move beyond the place where we are right now is recognizing that objective data in the context of training an AI system doesn't really exist. Like objective data, if you're doing a scientific experiment where you're trying to collect, measure an explicit physical quantity related to some apparatus and you're controlling that kind of makes sense. But actually, data in the context of training a model is a specification of how you want the model to behave, where you want the model to behave well. It's an encoding that we ultimately compile into a neural network of some kind. And so I think as we're thinking about synthetic data or sort of real data and kind of augmenting it in these particular dimensions, what we're really doing is we're acknowledging the fact that we have a subjective idea of what we want the model to do. And we're looking to encode that subjective goal into data. And that's really kind of the process that we're using. And in this sense, data is basically just a programming languages. In the same way, there's no objective Python programs. There's just Python programs that do what you want and Python programs that don't. And I think that's the same story for data here as well.
We could go on for another several hours, but we don't have it. So I would like to thank my colleagues and thank you for visiting with us.